to have David tonight. So David actually came to Singapore 1 year ago. He was actually visiting and speaking for a conference. I think it was for Oracle Worlds, if I'm correct.
Yep.
And it was pretty awesome. It was a really good meetup with him, and we thought to invite him again. And so today, we'll be more talking about core features of Java, what to expect in the future and what we have in the newest versions of Java. So we're very happy to have David virtually today and hope to have him in person again in the future. Thank you, David.
Thank you. Well, in fact, I was supposed to come back, I think, in June. But yeah, anyway, thanks for having me. So despite the hot situation, I'm very happy to be able to give this remote presentation. So the title of the session is Java in the 40 version. The thing is that more and more I realize that given we have accelerated the cadence of the Java release, people are somehow confused about what's in Java. So today what I want to share with you is basically what features will be added in 2020 in the Java platform. Why 40? Well, I'm French speaking, and I always confuse 40 and 14. So given that we have just released version 14 of Java, this is really what I'm going to talk today. Having said that, I will also discuss about Java 15, which will come later this year in 2020. So this is a standard safe harbor disclaimer from Oracle. Don't make any purchase decision based on what I will say today. Having said that, everything is open source, so we are good on that side. The only thing that you should keep in mind is that anything that I say about Java 15 can, in theory, still change. I mean, Java 15 will be released in September, so between now and then, there might be change. That's the only thing that you have to keep in mind about this disclaimer. Okay, May is a very important month because we are about to celebrate the 25th anniversary of Java. So Java has been released, the first release has been released 25 years ago. So we are just about to celebrate that anniversary. The thing is that Java keep evolving since 25 years based on two core principles. The first one, developer productivity. Second core principle is application performance. This has been done through the last 25 years in the face of constantly evolving things, such as programming paradigms. For example, 20 years ago, we're not really talking about any kind of functional programming when we were talking about Java. That's something since then that has become more and more important. Something else that evolved is application style. In the beginning, we were mainly talking about client-server application. We're talking about monolith application. Those days, obviously, it's more and more about microservices. So this is yet another evolution that Java has to cope with. Deployment styles. In the early days, we were deploying in our own data center on large server. Those days, we tend to deploy using containers in the cloud. So that's another big shift when it comes to the way we deploy our application. And again, Java has to cope with that. And last but not least, obviously, the hardware is evolving. So those days, for example, we have more and more cores in our machines. We have more and more memory. We have vector support directly built into general purpose computers. We have multiple level cache when it comes to memory, and so on and so on. So this is basically how Java has evolved for the last 25 years, and this is how it will continue to evolve. So this is a pretty busy slide. I'm not going to spend time on this slide. This slide basically lists all the features that were added in Java 9. And Java 9 was a special release in the sense that it was the latest large release of Java. And there's a big issue with that. So every 2 to 3 years, we were releasing one Java version with a bunch of features. So when it comes to adopting those features, it was very difficult because the developers basically had all of a sudden access to a bunch of features. So getting familiar with those features was very difficult. So we decided to change the way Java is evolving. So now how it works, This is something that we have put in place end of 2017. So every 6 months, there's a new Java release. So it's called a feature release. So 11, 12, 13. The current Java release is 14, released in March, and in September 2020, we're going to release 15. That's a given. 6 months later, 16, and so on and so on. Now, all those feature releases are open source and are supported until the next release comes out. So 9 was supported at least until 10 comes out, and so on and so on. So that means that today 14 will be at least supported until 15 comes out. And when 15 will be released in September, the current release will be 15. And that's basically, if you're on the open source side, you should use that version, because that's the version that is supported. Now, we also acknowledge that there are some users, typically enterprise, they are not able to move that rapidly. So moving from 14 to 15 is in itself not a big work, given that there are not that many features between all those releases. But still, there are some type of user that prefer to stick to one release for many years. So that's why we at Oracle have decided to have long-term support release. So basically, a long-term support release is nothing more than a given feature release that we take and we maintain for a very long time. 11 is the current LTS. The next one will be 17. So those releases will be supported for many years, despite the fact that obviously we will still have every 6 months a new features release. So basically, it provides choice. Either you use the OpenJDK build that Oracle is providing. They are free. The only thing is that if you are using those builds, well, you'd better keep with the Java release cadence. So right now, ideally, you want to be on 14 because this is the release that is supported, and that's also the release that is getting the security updates. If you are not able to move that quickly, Oracle also sells support for Java. That's the Oracle JDK. So when it comes to buying Oracle support, there are two things that you should look at. The price of that support. Honestly, the price of the Oracle support for Java is pretty cheap, but I will let you judge that. The only thing that you need to look at when you decide where you want to get your support for Java is basically the ability that the organization you are looking at is able to support you. And this slide shows the number of issues that were fixed in this particular example in JDK 14. And we clearly see that Oracle is clearly the company that contributes the most to Java. So the takeaway here, Java is still free. There has been a lot of confusions regarding that, but Java is and remains free. So now let's quickly discuss about how can we enable faster innovation within the platform. So the first thing that we put in place 2 or 3 years ago was this new release cadence, where every 6 months we have a new release. We also have the JEPs mechanism. So JEP stands for JDK enhancements proposal. So it's basically a mechanism that we use to introduce in the platform new Java language features, new JDK features, or even we're using that process to remove things from the platform, or we are also using that features, for example, to evolve how the OpenJDK project is managed. So it's basically some kind of lightweight mechanism that is clearly documented and tell the community how things are supposed to work when it comes to doing something non-trivial into the platform. Next to that, we have also put in place multiple feedback mechanisms that we are using to get feedback on non-final features. So the thing is that whenever we put something into the platform, as soon as it's final, it's something that is there forever. So it's basically, it becomes permanent. So we'd better get it right before we turn something into a permanent feature within the platform. So for that, we have multiple mechanisms that we can use to basically give to developers non-final features. We encourage developers to use those non-final features, and based on the feedback, we can still do adjustment to those features before we make them permanent. So we have the preview features mechanism. which is used more for language, Java language features. We also have experimental features, which we use mainly for hotspot VM features. And then we have additional mechanisms such as incubator modules, early JDK access build that we use to basically give access to prototype of new capabilities that we are thinking of adding into the platform. And last but not least, we have an ongoing OpenJDK project that is named SCARA. So the goal of SCARA is to investigate alternative to Mercurial. So if you know OpenJDK, you know that for many years OpenJDK, well, in fact, since the beginning, OpenJDK has used Mercurial as its source code management solution. It works for many years, but honestly, Mercurial is a bit tough to learn. So if we want to encourage more contributions, well, we'd better look at alternatives. So that was the goal of that project, look at alternatives. And the outcome is SCARA has selected Git as the alternative. So that means that all the OpenJDK development is moving to Git. SCARA has also looked at hosted Git providers. GitHub has been selected, but clearly SCARA and OpenJDK is not tied to GitHub. So if something goes wrong with GitHub, we can easily switch, despite the size of the project, to a different Git providers. And last but not least, SCARA has also looked at how we can improve the complete development lifecycle of OpenJDK by adding on top of Git some additional toolings. So a bunch of OpenJDK projects have already moved to GitHub. We have the list here: Amber, SCARA, GMC, Loom, and so on and so on. And all the rest, obviously, are planned to move. In fact, we plan to move JDK itself either around, I think, end of JDK 15. So that would be still in 2020, or around early 16. So still in 2020. But still, all the projects are have read-only mirrors on GitHubs. So basically, all those bullet points give us the ability to enable faster innovation within the platform, something that we have already used, and we clearly see the benefit of all of those tools. Sorry. So delivering faster. So we have enabled the ability to deliver faster. And well, let's look at what we have delivered recently. When I say we, it's really the OpenJDK community. Obviously, Oracle is a big player in that community, but it's not just Oracle, right? So Java 10 delivered in March 2018. Those are all the features. I'm not going to spend any time on those releases because we already have enough to cover with 14 and 15. The only thing is that you might see that we have two JEPs that are in kind of yellow-orange color. Those have been delivered by someone else than Oracle. So the one in blacks are coming from Oracle, and the other one are coming from other OpenJDK members. And I believe those two are coming from Red Hat. Then we had 11, which was a pretty big release in terms of capability. The thing to keep in mind is that any features release is driven by the dates. So it's either March or September. They are not driven by features. So if a feature is not ready to be included in a given feature release, well, it's not an issue. That features will just have to wait the next feature release. 12, March 29. 13, September 2019. 13 was clearly a relatively small release, but yeah. Anyway, 14, that was released 2 months ago, basically, well, cope with the fact that 13 was really modest. But again, the only thing that did drive those releases is the dates, not the content. So today we're going to discuss some of those JEPs that have been added in Java 14. Again, we see that there are two JEPs coming that are not coming from Oracle. Non-volatile map byte buffer, I think, is coming from Red Hat, and helpful null pointer exception that we're going to discuss later is coming from SAP. Okay, so Java 14 was released in March 2020. Everything is open source, so gdk.java.net/14, you can have access to the OpenJDK builds of 14. You can also have access to all the technical content regarding that release. Now, quickly, Java 15. What do we know about Java 15? Well, first and foremost, we know that Java 15 will be released in September 2020. We also know the schedule. So we know that Rundown phase 1, that's basically when we have the feature freeze, is in 1 month from now, so 11th of June. So today, based on the information that is available in the OpenJDK project, we can already discuss about what's being planned within 15. That's what I'm going to do today. Now, keep in mind that things can obviously still change. We can add things at the very last minute, or we can even drop things at the very last minute, depending on, well, on some stability issue or something else. Things might still evolve. So those toolings basically gives you the content that is plain for 14. So we clearly, well, it's a very interesting time for Java because we clearly have a very rich pipeline when it comes to features. Why? Because, well, I wouldn't say many years ago, but 5 to 4 years ago, we have decided to work on very ambitious project, multiple projects that were long-term R&D projects, and they each had a goal to basically either fundamentally improve certain aspect of the Java platform or even revamp a given aspect of the platform. So I'm going to discuss some of those today: ZGC, Ember, Panama, Valhalla, Metropolis, Loom, and so on. So very quickly. The first one that I want to discuss is ZGC, Zero GC. So it's a low latency scalable garbage collector that we started to work on a few years ago. It was introduced as experimental features in Java 11. And the main goal of ZGC is basically gives you the lowest latency possible. So it's a concurrent GC, meaning that all the heavy lifting work of the GC is done basically while your Java threads are being executed. So there are a few posts, but they are reduced to to the smallest possible, to the smallest time possible. We claim that the post time should stay below 10 milliseconds with ZGC, but what we observe is that most of the time the posts are more around 2 milliseconds, which obviously is very low. It's scalable in the sense that the post time will not increase as you grow your heap or your live sets. So the 10 millisecond post time is something that you would get typically on a 1 gigabyte heap, but also on a 1 terabyte heap. So there's no change in that front. ZGC in the early days was designed for large heaps, multi-terabyte heaps, but it turns out that there are use cases where it also makes sense to use ZGC for smaller heaps. So one of the features that we have added recently is the support for a few megabytes heaps. I think that the lowest that we can go is 8 megabytes. So how do you use ZGC today? So I mentioned that ZGC was added as an experimental feature in Java 11. So you need to unlock explicitly ZGC. So there is a specific hotspot flag, unlock experimental VM option, to basically unlock any experimental feature of the VM. So you do that, and then you use the specific flag to enable ZGC. So basically to tell the VM to switch from G1, which is the default GC, to ZGC. And there you go. Then the thing that you might want to do is tune ZGC. To tune ZGC, the thing that you need to do basically is just set the heap size. One of the design goals of ZGC was also to provide a default behavior that avoid any tunings. Obviously, you still have the ability to do more tuning than just setting the heap size, but by default, ZGC should give you a good result with just setting the heap size. So ZGC, what is the history behind ZGC? ZGC was initially introduced in 11 as an experimental features on Linux. We have added additional capabilities in 12. In 13, ZGC support was added for ARM64. And finally, in 14, so the release that we have done 2 months ago, is adding support for macOS and Windows for ZGC. And the plan is to make ZGC as a production feature. So basically, we are removing that experimental flag from the feature in JDK 15, so this year. So this is a picture that I took earlier this year in Sweden, and on stage was Monica Beckwith from Microsoft. And well, that's her claim. It's not my claim. So ZGC shine when it comes to responsiveness. So I encourage you to check her presentation, which is now online, where she goes basically about the benefit of ZGC. Now, let's quickly talk about G1GC. So G1GC is the default GC. Obviously, we have made a lot of investment within ZGC, but that doesn't mean that we are not looking at improving G1. So, for example, in 14, we have added support for NUMA. So NUMA stands for non-uniform memory access. So basically, that means that some memory might be, well, the distance between the memory and the cores is not always equal. So from one core, accessing a given memory might be more expensive because it's more distant than accessing memory in a different part of, well, from a different cores. Parallel GC was NUMA aware since a long time. So in 14, we have added NUMA support for G1. And that's not all. If we look at the number of enhancements that we have done in around G1 since JDK 8, it's over 700 enhancements that together greatly improve G1. So the charts shows, for example, so the charts below shows the native memory overhead caused by your G1 GC for a heap size of 16 megabyte. And what we can see is that, well, if we look at JDK 8, the extra native memory was around 4 megabyte. In 11, it was around, well, it was below 3, sorry, I said megabyte, it's gigabyte. So 8 need an additional 4 gigabyte to GC that large heap. JDK 11, it was reduced to, I think, 2.7 gigabyte, and in 14, it has been reduced to 1.7 gigabyte. So basically, you see that by switching from 8 to 14, we have greatly reduced the memory footprint of G1. Not only that, we also improve the performance. So basically, when you put together all those 700 enhancements, that improves G1 a lot across all our areas. So throughput, footprint, latency, and so on and so on. So that's something that you need to consider if obviously GC. Well, the GC, those GC characteristics are important to you. You need to think about moving to a newer version of the platform. So this is another chart that shows some of the enhancements that have been done to G1. So let's see. This is using the standard spec GBB benchmark. So this one is using a fixed heap, so set to 4 gigabyte. All the results are normalized, and higher is better. So we have max GOPS and critical GOPS. Both are looking at the throughput. The thing is that critical GOPS is looking, in addition to throughput, is also looking at latencies. So we can see that parallel GC has been increased. So the performance of parallel GC has been increased between 8 and 14. But we can also see that there is a huge boost in terms of latency improvement when it comes to G1 in 14. Having said that, if we look, at this slide, at the next slides, we see in this particular case, so this is with a heap of 16 gigabyte, that there has been a regression between 8. Well, I don't have the result of G1 here, but we can clearly see that there is a drop. So we had a regression, basically. And I don't remember the exact issue. If you want to know more about the given bug, it's you just need to check the blogs at the bottom of the slides. But that issue has been solved. So we can clearly see that G1 in 15 will improve the latencies. We see that the throughput is is, well, there is a slight drop in terms of throughput, only 97% versus 100%. Well, it's a small, basically a small trade-off. But when we see the benefit that it gives in terms of latency improvement, I think that it's fair to say that it's okay to pay that small price. So quickly, startup time is something that we always look to improve in all the Java release, and obviously 14 is not an exception. Now we can see in this case that the startup time for a given, it's a small application. It's basically a Hello World application. There is a small improvement. Obviously, as faster we get, the more difficult it is to find large improvement. But still, between 13 and 14, the startup time has been improved, and I can already tell you that between 14 and 15, it will still slightly improve. Now, this is basically the same benchmark, but with different scenarios. So a Hello World application, a Hello World application that uses Lambda expression, and then a Hello World application that is using a concat string. And again, you basically see that across all the release, we are improving the startup time for those different scenarios. So that's something that, again, is useful over time whenever you switch to a newer version of Java. So now let's talk. So we have discussed about ZGC, which is one of those ambitious projects, basically adding a new garbage collectors that provide low latency. Another one that deal with memory is Project Valhalla, and that is a clearly very ambitious project. So the goal of Valhalla is basically to reboot the relationship that the JVM has with the data in memory. So if you know Java, you know that Java is very good at optimizing code. We have, for example, a JIT compiler that will improve over time your code as it runs. So on that side, we're good. But the next step is really to look on how we can optimize data in memory. Now, there's an issue. We have the Java type systems, something that obviously is very powerful, but there is a price to pay, and sometimes we miss a bit of flexibility. And that's basically due to the fact that each object has an identity. It's something that obviously is needed. We're not going to get rid of object identity. It enables mutability, polymorphism, and so on and so on. On the other hand, there are some use cases where objects might not need identity, but still, today they have to pay the price for that features, even though those objects might not benefit from identity. So basically, Project Valhalla is looking at how we can improve the density of information within memory. And the thing that the team is looking at is basically how we can declaratively say that, okay, for that type of object, I don't need that object to handle an identity. It's not something that can be done automatically. So that will involve some help from the developers. So the developer will have to specifically say, okay, for that type of object, I don't need identity. And then the VM will be able to improve how those objects will be stored into memory. And the VM will be able to increase the density, the in-memory density for those type of objects. Another project is Project Loom. So if you look today, there are, well, I will simplify a little bit, but there are two types of programming approach. So you have a traditional blocking approach. So it's very easy to program, to develop with. The thing is that, well, it's very easy to develop. It's also very easy to debug. The thing is that approach doesn't scale. As soon as your code blocks, well, basically your code is waiting for something to happen. So you are you are blocking resources. That's not very effective. On the other hand, you can go for a model that is more geared towards a reactive approach. The thing is that developing reactive application, well, that's on one hand a very difficult model to program with, and more importantly, that the code you write is very difficult to debug and hence to maintain. Typically, if you try to debug a reactive application, well, you see that you have an issue here, but in fact, the issue is not really happening on that. Well, in that region of the application, but it's happened somewhere else. But it's very basically, it's very difficult to do correlation between an issue and where it happened within the flow of the code. But still, if you want to scale, if you want to have efficient resource use of, you need to go toward that approach. So Project Loom is basically trying to solve that by making concurrency simple again. How? Right now, the JVM is using native threads, kernel threads. Loom introduced the notion of virtual threads, which are basically threads that are managed by the JVM. So those threads are some kind of virtual threads, software threads that are managed and scheduled by the JVM. And obviously, the JVM will have to do mapping between those virtual threads and some underlying kernel carrier thread, but that is handled by the JVM. And the thing is that those virtual threads are very, very cheap. So it's not really an issue to write code that is blocking, because the virtual thread that is blocking is not blocking an actual underlying physical threads. So basically, you can write application using virtual thread. Your code can blocks, but you don't have to pay off resource underutilization. So those threads are so cheap that you don't even have to pull those threads. So you just block the thread and you start a new thread. It's not an issue because those threads are very cheap. So that's basically what Loom is trying to solve. Now, those days, we have multiple early access build of Loom. If we look in the platform, there are already a few JEPs that have been added in the platform for Loom, and more specifically in JDK 14, we have re-implemented the legacy socket API. That was something in preparation for something that is coming in JDK 15, which is re-implementing the legacy datagram socket API, which has been done in preparation of Loom. So another large project is Panama. So the goal of Panama is basically to enrich the interaction between the Java virtual machine and foreign native code. Historically, we had JNI for that, Java Native Interface, but JNI has been specifically designed in the early days to be, I would say, not friendly to use. We want to basically provide an alternative to JNI where it is easy, safe, and efficient to use from Java native, to use native code from Java. If we look at the deliverables of Panama, there are three main deliverables: the foreign memory access API, which is in 14 in Incubator. So that's something that you can use already today. It basically allows to efficiently and safely use of memory that is not on the Java heap, but you can access that memory from Java code. Then there's an extraction part. It's basically the ability to extract from C native header files. Extract interface and generate binders that you can use directly from Java code. There are two parts for the extraction part. There is a tool that mechanically do the extraction, but there's also an API that more advanced developer can use to meet more advanced scenarios. And last but not least, there's the vector API, which allows to easily express vector computation that will compile at runtime and execute on a vector on CPU that support vectorized extension, such as SSC or AVX for AMD or ARM scalable vector extension. And the vector API is right now in Incubator candidate, so we don't know yet in which JDK release it will be added. So today what we have for Loom is the foreign memory access API in Incubator. That's something that you can use. And we also have early access build for the extraction part. And then I also put this in the Panama part, even though that specific JEP is not really part of Panama, but given that it's very close to the hardware, and I put it here. So JEP 352 basically had the ability to manage non-volatile memory via byte buffer. That's something very specific, so I'm not going to discuss about that anymore. So what I'm going to do now is a very small Panama demo. So it takes a bit of time to switch. Okay. So let's see. So I hope that it's big enough. So what I have here, I have a very simple Java application, but first I'm gonna go, let's see, where is it? No. So I'm on OS 6, this is a Linux. So as in Linux, no, I don't want to do that. I forget the name. Sorry, let me check. Okay, this. Oh, sorry, too small. No, it's readline. So this is a header file that is part of OS 6. So this is a readline library that basically gives us readline support, something very basic. So there are multiple functions, and what I want to do here is use one of the readline function from Java. So the first thing that I need to do is use the extract tool to basically parse the readline header files to extract all the information and then generate the binder interface for that. So I'm going to use this gextract tool. So, and I specify here that this is the path, for example, of the library, the readline library. This is the path of the header file that we want to extract. And what I want is that I want the outcome to be in that jar file. Obviously, I'm not on the right version. So let's see, I'm on 14 and I need to switch. So I'm going to switch to a specific GDK build that support Panama, and it's 14, I think. Oops, Panama, yes. So let's invoke gextract again. Okay, a bunch of warning, but this is an early access build. Okay, now I have this jar that has been generated. So what I want to do is basically, I have this small Java application. We can very quickly go over the code of that application. So a scope is something that is provided by the foreign memory, the foreign memory API of Panama. And basically, scope are used to enforce liveness checks on scope resources. So it's basically some sort of memory, but that we will allocate on the other side, so on the native side. We need to enforce liveness because whenever we allocate on the other sides of the fence, so on the native side, obviously at some point in time, what has been allocated needs to be deallocated. So that's why we need scope. So I create a scope. Then from that scope, as I allocate a string, I pass in the string name. So we're on the C side. And then I'm just invoking that function that is coming from the readline library using this pointer that is defined here. So basically, I'm just passing this string to the native function. And what we get in return is a P object, which is a pointer. And then I'm just displaying that object. So this is a toString method invocation on the P, so on the pointer object. And then I use this static method to basically get the content of that pointer. So let's compile that. So Delabassee. Let's see, class pass. I need to specify the jar, readline, and then the source. Okay, now I need to run that guy. So name. So this is basically this line here where we invoke the read line. So this is the C OS 6 function that is invoked. I pass it something test, and then the result is the following. So it's so the type is a bounded pointer. So this is this line, in fact, the toString on that P object, which is a pointer. And then so this is all the result all the toString information, all the information that we get via the toString. And then the last thing is this test, which is basically we ask the foreign memory API to give us the content that is pointed on the other side of the fence, but by that given pointer. So this is in a nutshell how Panama works. So if you have any question, you can use the chat or we can discuss at the end. It's up to you. So moving on. Another big project is Project Amber. So the goal of Amber is basically to continuously improve developer productivity through the evolution of the Java language. So it's not something that happened through one single release. It's something that we have started around Java 10. And since Java 10, we have added new features which are basically emerging from Project Amber. var is a big one. So variable type inference was added in 10. In 14, we're adding switch expression. It becomes a standard features after 2 rounds of preview. We're doing another round of preview for text blocks. We are introducing records. We're introducing also pattern matching with instance of in preview 2. So I'm going to discuss most of those features. So the first one is records. So records basically give you the ability to, so they are providing a very compact syntax for declaring class, which are data holder. So basically a tuple, an immutable tuple in which you can store data, and that's something that you can basically pass around. I'm going to show you how it works. So you will see that, well, it's something that is on one hand very simple, but on the other hand very efficient. Something else that is coming from Amber is text blocks. So basically text blocks are multi-line string literals. So take the following example. So you want to store the HTML that we have on the left side. Typically, you would do something in your code. With text blocks, you can now do that. So you basically keep the syntax as it is. You don't have to escape anything. This is something which is very convenient for dealing with XML, JSON, YAML, SQL, and so on. But again, that's something that we will see in a demo in a minute. Then we have pattern matching. That's something that we will see in the demo. It will be more clear. And finally, we have a new switch expression. So let's go to the demo that will be more concrete. So let's see. Well, IntelliJ is already started. So I'm going to very quickly create a new project. I need to configure my compiler because I don't know why, but by default it generates Delabassee 5 bytecode. And then I also need to configure my project. And I'm going to increase the font for the code, don't worry. So here, given that I'm going to use, oh, sorry, it's not here, it's here. Given that I'm going to use some preview feature, I need to specifically tell to IntelliJ that I want to use preview features because preview features are not enabled by default. And I also need to do it, let's see here. So again, I'm going to use 14 preview features. Okay. So source main. Okay. So let's just run that and see if it works. Okay, yeah, it works. So the first thing that I'm going to show you is records. So let's create a record. Let's say that we want to create a record for a person, and a person as a name, and a person as a first name. And that's it. It's all we have to do. Now what I can do in my code is the following, for example. So I can create a record. And today's speakers is Delabassee David. Oops. Oops, sorry. It's obviously not a record, but a person. Okay. So now I have the speaker object that I can use. So for example, speaker. So let's run that. So this is the result. So this is basically the toString method that is invoked on that speaker object. So let's have a look at what has been what we have here. So target class. We should have two classes. So we have the test class and we have this person class. So this is our record. So if we look at the record itself, so just by this simple declaration, we see that we have a few methods that have been generated. So the class person is final. It extends Java-lang records. It has a few methods. So it has a constructor. It has a toString. It has a default hashcode method. It has an equals, and then it has two getters, last and first name. So that means that I can, for example, invoke one of those, and you see one of those methods, and you see that this time we have the Delabassee instead of the toString. So what we can do, if we look at the record itself, obviously this is the default behavior. I haven't specified anything. I can define my own constructor. So person. I can say, for example, that, let's see, we want to uppercase all the names, right? So let's run that. So you see that, oops, Delabassee is now in uppercase. And you see that the only thing I had to do is basically, I just have to specify what needs to be done with one of the field. I didn't have to specify anything for the first field, so it has the default behavior. But now if I'm doing something like this, for example, if, let's see, last is blank, then this last equal, no, Nimus. Here the compiler will complain because last might not have been initialized. So if we go through this branch, of course, last is initialized, but that means that if we have an else, it won't be. So if last name is not blank, it won't be initialized. So to solve that, basically, we need to add in this case, a else, and so else this last equals last. In this case, we have a default, a second branch, and in this case, it works. So if I have a blanks, let's run that. And you see that this time, oops, sorry, it's the first name is anonymous because it is blank. So that's basically how a record works. The next thing, text blocks. So let's see. For that, I'm gonna, yes. So this is the POM that has been generated. So it's just some XML. So it's the POM from my project. And well, I want to create a string for that. So for that, I'm going to use a text block. So for that, I'm use the triple quotes. And that's all it takes. Now I can do, so POM south if I run that, well, you see that the text blocks is correctly, including the indentation, because here I basically copy the HTML as it was. So what I've done here is basically I kept the indentation, but obviously we probably don't want to have all those space in front. That's something that text block handles for us. Something else that we can do is, for example, the following with text blocks. So they're not able to evaluate expression, but well, let's just do that. So added percent has here, and now I can use formatted. And let's see. And what I want here is the speaker first, for example. So let's run that. Yep, sorry, typo. It's a method. So if we look at the HTML, we see that well, it's not class, but it's the first name, but you get the ID. So basically we can do some kind of cheap expression interpolation using formatted with text blocks. So that's basically how text blocks works. Now let's move on to another features of Humber, and that's pattern matching. So pattern matching. So you see we have this speaker object, which in fact is a person. So that means that we can do something like speaker first, right? So we would get David, but it might happen that the type of that object is of that speaker would be object. In that case, obviously, we cannot directly invoke the first method. So what we would typically do is something like this. So if speaker instance of it's a person, so if it's a person, then what we do, we create a new object. So it's a person object, x equal to a speaker, but we have to specifically cast it to a person type. And here, obviously, we want to use the X object, so that works. So the thing is that here you see that if we have this type, we create an object of that same type, and we cast it from the other object using that same type. There are a lot of repetition going on. What we can do now with pattern matching instance of in JDK 14 is the following. So we declare the new variable here, and that's it. So if you run this, we'll get the exact same behavior. So hello, David, this is the first one. And hello, David, this is the second one. And you see that this one is more succinct, so it's more obvious to use. So the last one, and I'm probably going to skip that one because it takes a bit of time, is the switch expression. So it's a new type of switch expression. That works like this. So this is on the left side. This is how it traditionally works. The thing is that, for example, here there is a bug in the sense that there is no break here. So if I do a switch on, let's say, Friday, well, number of character will be 6, and then it will be 7. So that would be the end result, 7. In this case, I'm doing a switch over an enumeration. So all the values are no because we're in an enumeration, but still. If I miss, for example, one of the day, the compiler will not be able to tell me, okay, you are not evaluating Wednesday, for example. So that's why we have a default. But given that we know all the value, the default is a bit, well, it's a bit hard to have to use a default value. So what we can do, oh, there is a question. Will we be able to use record as GP entities? Not directly. Something that, well, you can use records with GPA, but the thing that you have to keep in mind is that records are immutable. So you cannot change any fields as soon as it has been created. So let's go back to this to the switch expression. This is the new switch expression. It basically returns the value directly. So something we were not able to do in the former switch expression. So that's why this is on the left side the switch statement, and this is an expression because it returns the value. So we have all the case. Given that again we're doing a case on enumeration, the compiler will tell us if for example we're missing a day. So if we're missing a day, either we had this day or we have to deal with the default value. If we're dealing with all the days and if we have a default value, the default will never be reached. So that's something that the compiler can also infer, that the default branch is basically a dead branch, those kind of things. So that's in a nutshell the switch expression. So I'm going to move a little bit because I'm a bit ahead of time. Oh, sorry, shouldn't. My bad. I switched the slide. I shouldn't moved out of the slides. So the Ember demo, we have seen the Ember demo. So those are some of the projects that the more ambitious long-term project that we're working on. What we see is that gradually some of the features emerging from those projects are added in Java. So we've seen the foreign memory coming from Loom, for example. We've seen how Ember has added multiple features since Java 10 in the Java platform. But obviously, the Java platform is not all about a huge and ambitious project. In 14, we have this new helpful null pointer exception, JEP 358. So we have all seen that kind of code where we basically have null pointers. So it's not a big deal because we know where the null pointers happen. So line 666. So we just have to look at that line, right? The thing is that line might look like the following. So we know that it happened here, but we really have no idea where it happened exactly. That's what the null pointers, the helpful null pointers option gives us. So that's something that you have to explicitly enable in 14. And now you will have something like this. So it cannot involve the city get district because the return value of get city is null. So it basically gives us more information to help us to pinpoint the exact issue that raised that null pointers. So that's something that is available as a standard feature in 14. It's not enabled by default. And I've seen some discussion where in 15 it might be enabled by default. So it's a small features, but it's a very convenient features. GDK flight recorder is something that is available, I think, since Java 11. And the basic idea of GDK, of flight recorder, GFR, it's a black box that keeps track of events that are emitted by different components within the GDK itself. So it can be the JVM, it can be your code. So a bunch of events are raised, and GFR will keep track of them. And that's something that you can use after the fact to do some kind of analysis. The thing is that GFR is very low overhead. So that's something that you can use in production to basically detect and pinpoint specific issue. Something that we're adding in GDK 14 is event streaming. So until now, the way you were using GFR was the following. So you start the recording of your application. You use your application, then you stop the recording, you dump the content of the event to a repository, and then you process those events. Now, an application that is running has the ability to stream out events as they happen. So you can basically do you can have some sort of sidecar application to do analysis of the event as they happen. So there is a specific API to do that in GDK 14. The thing is that obviously we are improving GFR through all the release. So in 14 we had 145 different event types for GFR, and in 15 I've checked in the latest. Well, it's not the latest build because we have done a 22 build yesterday, but in the build of last week we had 157 GFR event type. So it keeps GFR in itself keeps to have more metrics within the platform that you can use, and not only that, you can also write your own custom event type for your application. Something else that is part of JDK 14 is this new packaging tool, JEP 343. Right now, it's still in an incubation phase. So the idea of that tool is it's a tool that gives you the ability to create native installer specific for a given platform. So on Windows, you will either have an MSI or an exe file. On macOS, you will have a package file or a DMG, and so on and so on. And it has a lot of additional, I would say, native features, such as the ability to pass parameters to the native executable that will invoke, that will do the installation of your Java application. It obviously works with JLinks, and so on and so on. So that's something that you can use today to basically create native installer for your Java code. Now let's quickly look at Java 15. So that's the schedule. Nothing will change on that front. So this is a table that I did. Well, I did it yesterday, and I checked this morning. It was still up to date. So those are the multiple JEP that will be part of 15. I'm going to discuss specifically two JEPs. That is hidden class and where is the other one? Sealed type, sealed class. It's not here. Yeah, I don't see. Oh, yeah, I missed one. Well, anyway, it's on my slide later on. Oh, yeah, it's here. Sorry, it's it. The other one is sealed class. So, so this slide shows the JEP that are either integrated, so already in the early build of JDK 15, or they are targeted. So, targeted means that we intend to add them to 15, or we propose to target them. So that's basically the first step before we integrate them. So we tell the community, okay, we want to add that to 15. Is there any objection? If not, we will. It will move to targeted, and then once the works is done, it will move from targeted to integrated. So basically, there is a very high chance that all the JEPs here will be part of JDK 15. Just keep in mind the small disclaimer that we might find a big issue in one of the JEP here, and we might decide to remove it at the very last minute. So that there's always a risk. And then there are a few other JEPs that are currently being worked on, and we don't know yet if they will be part of 15. So one is sealed class, and well, there are a bunch of JEPs, but I just took 3 where clearly there are a lot of activities going on right now. So maybe they will be part of 15. We will see in a few weeks, and at worst by early June we will know for sure if they are part of 15 or not. So sealed class for in-memory access, second incubator, so that's part of Project Loom, and then the vector API, which is also part of Project Loom. So I'm going to very quickly discuss hidden class and sealed class, which are often confused. So a hidden class is something that is very specifically, that has been specifically done for frameworks developers. So if we look at frameworks, they have this habit of dynamically generating classes and use those classes through reflection. The thing is that those classes, given that they are generated, can potentially be used by other / external bytecode, something that we clearly don't want. So basically, the ability of hidden class gives now frameworks developer the ability to still generate dynamically classes on the fly, but those classes are hidden for the rest of the world. So only the frameworks that generate those classes will be able to use those classes. So it targets frameworks developers. But if we look at Delabassee, for example, Delabassee is also using that techniques, for example, for Lambda expression. So that's something that is also useful for Java itself. And one of the things that will be done in addition to creating this new facility is also deprecating the Sun Miscon Safe define anonymous classes that is used exactly for doing that, dynamically generating classes. So if we look at the properties of those classes, well, in terms of discoverability, they shouldn't be basically discoverable by classes outside of the classes that has created that classes. In terms of lifecycle, those classes should be able to be aggressively unloaded to give the frameworks the ability to generate a lot of classes. And as soon as those classes are not needed, they will be automatically garbage collected. Now, they can be garbage collected through a more traditional approach. That's something that is the behavior of the GC is configurable for hidden classes. But what we know for sure is that the aggressive unloading is something that is needed. And then access control. That basically gives us the ability for a class that creates dynamically another class to access that class, but that also prevents other classes external to that classes to access that newly created class. So that's basically in a nutshell hidden classes. It's not something that you're going to use, that most of the developers like you and me will use. It's clearly something for frameworks developers. And then there are seed class, and some people tend to confuse the two. They are completely different. So before we talk about seed class, we need to quickly talk about inheritance. So inheritance is something that encourages code reuse. So we basically have a class hierarchy, and all the class, for example, a class that extends the class can reuse features from the class that it extends for. Now, the thing is that the class hierarchy is is often used for code reuse, but sometimes it's used for something completely different. So the class hierarchy is sometimes also used to model different possibility of a given domains. So for example, we want to model the different shapes that are supported by graphic applications. So we would have a shape, a class or interface, and then we have subclasses that would extend that shape classes, like a square extend the shapes, an hexagon extend the shapes, and so on. Or we can have a class that represents the type of vehicles that we sell, and then we would have, I don't know, a SUV, a coupe, a sedan, and so on that extends that super classes. So that's something that is completely different. And the problem is that right now, if you have this shape superclass that is extended by triangle, circle, hexagon, and so on, you cannot prevent any other class to also extend it. And that's something that we would like to address with a seed class. So seed class would basically allows to have a given class hierarchy that is bounded. So the class hierarchy can only be extended by class within that limited closed class hierarchy and not by any external classes. And obviously code reuse would still be possible, but it would only be possible within domain, within the boundary of the closed class hierarchy. So how does that work? Well, let's have a look at an example that would be more obvious. So I have this shape superclass, and we have two new keywords. So we have sealed, that is used to basically say, okay, the class shape is sealed, and then we have the permits keywords that tells which class or interface can use that superclass. So sealed shape is sealed, and only in this example, circle, rectangle, and square are allowed to extend the shapes. And then there are a few variations, like the fact that if you are within the same package or the same modules, you can just use the class name. You don't have to use the full package name. If you have nested class, so all the classes within a single file source, you just seal the superclass, and by default, all the classes that are present in the same source file will be permitted by default to extend that superclass. So that's basically how it works. Now, it's not clear today if sealed class will be part of JDK 15. If not, that's not really an issue. It just means that we'll have to wait another 6 months, and it will be for JDK 16. So I think it's time to wrap up. So today we've discussed about what new features will be added to Java in 2020. So JDK 14 was released 2 months ago, and JDK 15 will be released in 4 months from now. I've also discussed very quickly on how those large, ambitious, long-term projects are basically gradually adding capabilities into the platform with the ultimate goals of revamping completely the platform. Now, I need to quickly discuss another new project that we have just announced 2 weeks ago, and that is Leiden. So Leiden basically tried to tackle some of the pain points of Java, and that is the slow startup time, the slow time to performance, and the large footprint of Java application. And everything is relative. When I say slow, it's slow compared to typically native Go applications, for example. Footprint, it's again compared to native application. So basically, Leiden tried to tackle those pain points by introducing the concept of a static image to Java, something similar to a GraalVM native image. Leiden aims to leverage existing component of the JDK, such as Hotspot, AOTC, which is an AOT compiler that we have in experimental form since GK9 into the platform, but also CDS and JLink. And clearly, this is just the early days of Leiden. We have just started to gather interest around that project, but we think that over time, this is something that will be important. So basically, bring the capability that we have with native VM, the similar capabilities, but directly into the Java platform. So these slides depict the content of JDK 14. I think that we have discussed most of the JEBs that we have here. The only thing that I need to mention, and I think I've mentioned that at the beginning, is that JEBs are also used to remove older things from the platform. So you see that, for example, 362 and 363 are deprecating things from the platform and or removing. So when we remove something from the platform, we first deprecate to tell the world that, okay, that features will be removed in the futures. And then later on, it will be actually removed. So it's a multi-phase removal approach. And JDK 14 is available. So you should download it right now and give it a try. So in terms of conclusion, Java is still free. We have put in place everything to deliver faster, and we are delivering faster, and we haven't had a richest feature pipeline for the Java platform ever. And also keep in mind, this year marks the 25th anniversary of Java. And given the pipeline that we have, well, we can clearly say that there's a bright future for Java developers. And with that, I'd like to thank you for your time. And I don't know if we still have time for questions.
Probably we have time for one question. Someone has a question.
You can also ask question on Twitter. So there's my Twitter handle there. So if you have any question and you don't feel like asking now, you can also ping me on Twitter.
I think Srini has a question.
Yeah. So this is a question regarding the project Valhalla. So there was the last thing I was actually looking into is the problem of type erasures in type erasure in generic. So that's a more complicated problem in Project Valhalla. So what is the state of it, and is that mountain climbed, and then when it's expected to deliver it?
So you know Brian Goetz, the Java architect. So Brian is the architect of the Java platform, and basically his answer is it will be so whenever someone asks about when it will be delivered, his answer is pretty easy. It will be available. It will be available when it's ready. And the fact that, well, it's not yet there means that, well, things are still being worked on. So I cannot give you any more precise answer than that. But yeah, you're right. Valhalla is really a fundamental change within the platform. The nice thing is that with the new release cadence, well, we don't have the issue that we had in the past, where we basically had a time window to add new features in the platform every 3 years. So if we miss that time window, that basically means that we have to wait another 3 years to add that into the platform. Those days, we can gradually add features every 6 months. So we can expect in the future release to come to see some features emerging from Valhalla. But I can't give you any more precise answer than that. I'm sorry.
Thank you, David. Thanks a lot for your presentation.
Thank you. Thank you for your time.
Okay. Thanks everyone for joining. So see you next time.
Thank you.
Thank you. Bye-bye.